Have you ever seen butterflies of the same species that look different from one another? What about seeing leaves change colors with the seasons? Well, this happens because of polyphenism and phenotypic plasticity. Polyphenism. Sometimes, a single genotype can produce a few distinct phenotypes. These different phenotypes arise because of different environmental cues. Spadefoot toads can change phenotypes depending on the environmental conditions. If there are many tadpoles in an area, some of the tadpoles will develop faster, grow larger, and become carnivorous. This is because the large amount of tadpoles leads to food scarcity, so the larger tadpoles turn to cannibalism in order to eat. Male dung beetles exhibit phenotypic plasticity in horn development based on larval nutrition, following a threshold trait pattern. Well-fed larvae grow into large, horned males that fight for mates, while poorly nourished ones develop as smaller, hornless males that use sneaky tactics to reproduce. This flexibility allows males to maximize reproductive success under different environmental conditions. Remember, polyphenism only has 2 or 3 discrete possible outcomes. Phenotypic plasticity. Different environments can lead to a range of different phenotypes, produced by one genotype, in a species. This tailors the organism to its specific environment. Unknown lizards exhibit phenotypic plasticity in their color change as a way to respond to environmental conditions. These changes allow the lizards to adapt to temperature changes, social interactions, and stress levels. This adaptability helps their survival by optimizing thermoregulation, social signaling, and stress responses based on environmental conditions. Arctic foxes exhibit phenotypic plasticity in the timing of their molt to adapt to seasonal changes in photoperiod, temperature, and local environmental conditions. Longer daylight hours in spring, or shorter days in autumn, trigger hormonal shifts that regulate coat changes. But factors like climate variability, resource availability, and geographic location can modify this timing. This flexibility allows Arctic foxes to optimize camouflage and thermoregulation, enhancing their survival in a dynamic Arctic environment. Remember, phenotypic plasticity leads to a range of different phenotypes. Why are these two things important? Understanding these concepts helps us to see how organisms adapt to their environments, how they evolve over time, and how they adapt to survive extreme conditions. Key concepts. Polyphenism means there are only 2 or 3 ways that you could look. Phenotypic plasticity means there are a variety of different ways that you could look.